Hi, kids. All right, I'm going to go through a combination circuit with you guys. So here is my lovely combination circuit. If you were watching this, I would recommend that you pause and copy it down so you have it. But it is a combination circuit because I have a series part here, I have a series part there, and then a parallel part right there. So it is a combination circuit. Anytime you're solving a combination circuit like this, you have to simplify it. And so we want to simplify it down to one resistor, and I need to find a part of the circuit that is only series or only parallel. So these two resistors are only series, so I'm going to simplify those two resistors, and I'm going to redraw my whole circuit. So and so that this is still 10 volts, this is 40 ohms still. This now 10 plus 20 is 30 ohms, this is 30 ohms, and this is going to be 15 ohms. Okay, so I've redrawn my circuit. I still have a combination circuit, so I need to simplify it again. So this time I'm going to go, I'll simplify it down here. So if I simplify it down here, now I'm going to have 30, 30, and 15. Those are in parallel to one another, so you have to use your parallel circuit rules. 1 over 30 plus 1 over 30 plus 1 over 15 equals 1 over the total. If you do that, you should get 7.5. I can do that in my head because I know these two are going to simplify down to 15, and then 15 and 15 would simplify down to 7.5. Otherwise, just do the formula, 1 over R1 plus 1 over R2, so on, equals 1 over the total. So, but if I redraw it, let's see, I want to make sure I can see it. Good. All right, so, okay, where this is 10 volts, this is 40 ohms, and this is 7.5 ohms. Okay, I'm going to simplify it one more time. So now I have, okay, 10 volts and 47.5 ohms. Okay, that means that my total resistance for this circuit would be 47.5 ohms. My total voltage would be 10 volts. Okay, now I can use my Vernas equation, because it's Vernas, and solve for my current right here. So if I take 10 divided by 47.5, I get 0.21 amps. And I would recommend, guys, using two different colors, or actually three different colors, so that you can keep everything track. So that this is 0.21 amps. So that means the total current that I have flowing in this circuit is 0.21 amps. My total resistance for this circuit is 47.5 ohms. Okay, now I have to work my way backwards. Okay, if you look, in order to go backwards here, I simplified a series circuit. So you have to ask yourself, well, what's the same in a series circuit? Well, series circuit only has one path, so the current's the same. So that means both here and here, my current is going to be 0.21 amps. So I'm going to plug in 0.21 amps. 0.21 amps. Then I can solve for, and here's where I'm going to use a different color. I can solve for my voltage here. I can solve for my voltage there. So 0.21 times 40 is 8.4 volts. Again, this is why you want to use colors, because it's going to be way easier to see. 7.5 times 0.21, 7.5 times 0.21 is 1.6 volts. Okay, now again, we can check this because we know any path that you take, the voltage has to add up. So 8.4 plus 1.6, it does equal 10 volts. Hooray, hooray. So now I'm going to work my way backwards. Okay, so what did I simplify here to get to here? I simplified a parallel circuit. So what's the same in a parallel circuit? My voltage. So I'm going to say, okay, so the voltage across each is 1.6 volts, 1.6 volts, 1.6 volts. This voltage is still the same, so it's 8.4 volts. And now I'm going to do my current. Well, the current for this was 0.21 amps. Now I have to use my Vernas equation and solve for my current for each of those. So 1.6 divided by 30 is 0.053 amps. This is also going to be 0.053 amps. And again, the reason why the different colors is going to be so important. And then 1.6 divided by 15 is 0.107 amps. Okay. Now again, if we want to check, okay, any path that I take around, my voltage has to add up. So 10 volts, 8.4 plus 1.6 equals 10. Cool. 8.4, 1.6, 8.4, 1.6. Cool. My voltage adds up. My current, okay, I had 0.21 coming out, and then it got to here, it's split up. So that means 0.053 plus 0.053 plus 0.107. That had better equal to 0.1 or 0.21. And if you do it, it's equal to 0.21, so hence I did that correctly. Okay, so then again, I got to work my way backwards. Okay, if I want to work my way backwards, I already know this stuff for my 40 was 8.4 volts. I know for the 15 was 1.6 volts. I know for my 30 was 1.6 volts. And then we have to ask yourself, what did I simplify here to get to here? Well, I simplified the series. What's the same in a series circuit? Well, there's only one path, therefore the current has to be the same. So the current for each of those is 0.053 amps. So I want to make sure you can see that. 0.053 amps. 0.053 amps. Okay. Now the rest of the stuff I'm just going to carry over from before. Okay, and then I can now find my voltage for each one of those, and my voltage is going to be, use your Vernice equation, 0.53 volts, and for the other one is going to be 0.053 times 20, 1.06 volts, and again, if we check it, any path that we take, so 8.4 plus 0.53 plus 1.06 essentially equals 10 volts. We did it right, and you can take any other path around that you like, and you're going to get your answer. The other thing you can do to check is I could find my power, and if I was going to do my power, I would actually make a separate power column, find my power for each one of these by doing I times V, and then that should add up to your total power, because remember, power adds up no matter what type of circuit you have. So there you have it. Enjoy. Bye, kids.